In this video, we'll be looking at the Kinect CHOP and creating interaction zones. Interaction zones in TouchDesigner can be a tricky thing to do because you're trying to build real space with virtual space. So generally what I like to start out with is actually a previs of the world as an abstract form. So in this case, I have two objects here. I have this geo zone, which is going to be the interaction zone that is the area that it is triggerable, right? Or when something enters this area, it has a trigger. And then I have this geo hand, which is going to represent a hand from this interaction moving in and out of this interaction zone. So the goal here is to, as I move this hand back and forth in and out of this zone, we trigger some text in this top to switch between outside and inside. So as we look around this thing, you can see that it's all dimensional in here. And as I move along the x-axis here, we want to make sure that as we move into this interaction zone, that effect is triggering. So we're going to start there. First, I'm going to hook up some of these chops that I have over here. This constant 2 is going to be connected to our zone. And then our constant 3 is going to be connected into our geo hand. And this is just so we can have some place to play around with these numbers as we move forward. So I'll make both of these viewer active and hook up their references using a CHOP reference. And this is so we can play around with these numbers using the sliders in the CHOP. So I can move this interaction zone to the place that I need it later on. So now I'll move or I'll reference the hand to its appropriate values. TX, TY, TZ, here we go. All right, so now, again, the goal is to move this hand into and out of this zone. So we need some way of tracking whether or not the hand object is inside or outside of the red sphere. And a good way of doing this, especially since we're using spheres, is to use the object chop. So I'll grab the object chop. And the object chop can allow us to perform calculations on two objects. So in this case, geozone and geohand. So I'll set up geozone as our target object, and I'll set up geohand as our reference object. And now you'll see as I move around the geo hand that these numbers start changing. And that's because it's calculating the difference between where this object is located and where this object is located. So, but really what we want is we want to know if the hand object is within the radius of the zone object. And luckily enough, the object chop has a computation that we can use. So if we set the output compute parameter to measurements, and then instead of position, we'll turn that off, and we'll use the distance. This will actually give us the distance between the origin of the zone and the origin of the hand. So now as I move this, we'll see that the distance is calculated accordingly. So if I just bring my hand to 0, 0, 0, you can see that we're only off by that 61 value, 0.61 value that the TZ has. And if I bring my zone back into 0, 0, 0, that distance closes. So really what we're looking for now is the distance greater than the radius of my interaction zone? And that's actually fairly easy to compute. So the spheres that drive this size are where we'll pull the radius from. So this radius is 0.5. So as long as the distance that's computed off of this object is less than 0.5, we can determine that the hand is within the interaction zone. So let's do this here with a logic chop. So we can take the logic chop, and it has a useful convert input function which gives us off when outside bounds. And that'll allow us to specify a bounds at which the logic is on or off. So for our case, we'll use this 0.5 as our reference here. And now as I move my hand in and out of the sphere, you can see that that triggers on and off for me. So that's good. That's going to be very useful for us moving forward. Just FYI, another way of using the object chop and determining distance is by using the position here. This txtytz is actually a vector between these two objects, and you can use the math chop in order to get the same information if you have a vector of length, which is here, length. So that should be another way that you can, I need to use combined channels, not combined chops. So that's another way of getting the distance between objects using the math chop. So now all that we need to do in order to get our effect to work and proof that this interaction is going to work once we hook up a Kinect is reference this distance variable into our text. So this is fairly straightforward. We're going to grab this table and drag it into our dat property here. And then the dat row is going to be referenced as this null. So now we can see that we are outside of the interaction zone. And as I move the hand into the interaction zone, that text should flip between outside and inside, which it is doing. So now all we have to do is hook this up to our sensor. So I actually have a Kinect Azure over here. So the Kinect Azure requires that it uses the Kinect Azure top in order to work accurately. However, if you have a Kinect, you shouldn't need to do this. So the Kinect, you should just be able to lay down the Kinect CHOP, and that'll get you all the information you need here. But for the Kinect Azure, I need to assign which Kinect Azure I'm using for my CHOP. And now you can see as I move my arm back and forth, my skeleton data tracks here. So this is important because we can pull this information over into our simulation and test that it works. So I'll be using the left hand positions here to drive that, that sphere, this geo over here. So we'll do that by just selecting out the left hand here. So we'll go over here and we'll grab the channel names. So the channel names will be anything hand, anything. Okay, so this is going to give us a bunch of different hands here. So I guess we'll just pull down to the left hand underscore L, and that'll give us the hand X, Y, and Z, which I can then just rename to TX, TY, and TZ. I can now plug this information into this null that we have already set up, and that'll allow my hand to enter this little simulation that we have. So as I move my hand around, you can see that the sphere that we had set up is actually moving. So as I move my hand in and out of our interaction zone here, we're getting more of that, that text moving in and out and doing our triggering in our interaction zone. So this was looking at interaction zones and the Kinect CHOP.